So this is for the 5.2 and 5.3 practice day 2. Yesterday we talked a lot about just like what is a parallelogram, what are the properties and theorems that we can use, and you can of course use your yellow like little foldable to help you, especially as you try these proofs out. It kind of helps to have this out as well as the new yellow sheet that has all of those same theorems on them, but you know exactly how to write it then. I think they are written similar on here, but the shorthand is of course on your yellow sheet that you can use. Okay, so the first proof, we're actually going to skip over this one. If you want to give it a try, of course, at some point today or sometime over break or even when you get back from break, it's a great one to try out at some point. But the answer key for this, and there's a video posted on Canvas, so you could always, try it out and then watch the video or just watch it to understand how to do number 1, because I think that this one's a little different in terms of like the parallelogram that we're working with is just the one that's inside here, so it's just A, B, C, D. Although it looks like the other one is also a parallelogram, it never tells us that, so we can't assume. It also tells us that D, F, and B, E are congruent. So with that information and anything from your yellow sheet, again, you're trying to get to a point where that entire AE is congruent to FC. And a lot of people want to try to just say, like, if parallelogram, then two pairs of opposite sides congruent. And the problem with doing that is we don't know that this big one here is a parallelogram, so you can't just say this entire thing is congruent to this entire thing, which is what the proof wants you to do. Instead, it's going to involve segment addition postulate with these two segments, because you are going to be able to show these segments are congruent to each other because of the theorem, and kind of go from there. So again, if you want to come back to number 1 and try it out, let's go through number 2 though, because there is something similar to number 2 even. There's some on the homework, some on the quiz, of course. There'll be one proof on the quiz that would be more similar to like number 2, and then even the test. Okay, so starts with telling us that it's a parallelogram PQRS. That's all we know. But surprisingly, that gives us so much information because parallelograms have so much detail that comes with it, right? So anything that's these 4 that say if parallelogram, then we can pick from. Now technically, we could pick from these other ones that say if parallelogram, but the problem is they say if parallelogram is a rhombus or a rectangle or a square. We're not dealing with those. But your options are the first one, which tells us parallel lines, opposite sides are parallel, or any of these 4. So let's see what's going to help us as we try to prove JX is congruent to KX. And so my first thought is usually if there are triangles within the parallelogram, and let's notice that this segment here is a part of a triangle, it's probably going to be easiest to try to prove the triangles congruent using our same triangle congruences that we've done just in the last unit, these guys. And then from there use the if triangle is congruent, then all corresponding parts are congruent. Okay, so that's kind of the route we want to take. But let's figure out which triangles we want to prove congruent first. And so you have a couple options. You could do these smaller ones or these bigger ones, but I would not pick these guys on the left and right because that doesn't include the segment that we want to eventually prove congruent. Okay, so we could pick these triangles. I'm just going to pick this one, but you can try out the proof the other way using the other ones. The only thing you'll have to look for is, do I have enough information to prove those triangles congruent? So you might get to a point where you think you do, and then if it doesn't work out, then you could stop. But it should work actually, because I think it's going to be the same number of steps. We could use like vertical angles whenever you see them, alternate interior angles, because we're going to have some lines that are parallel when you deal with the parallelogram. And also notice the diagonals are drawn in. Anytime a diagonal is drawn in for a parallelogram, you're probably going to want to use that one theorem that says if parallelogram, then diagonals bisect one another, and that'll help me kind of also. So you get to decide where you want to go, but let's start with our first step because that's the easiest, and write down parallelogram PQRS, and I'm just abbreviating that because we can. Okay, so then my second step, I could either start with if parallelogram, then diagonals bisect each other. That's one possibility. Or I could start with if parallelogram, then two pairs of opposite sides parallel, where I'm referring to these two opposite sides here, PQ and RS, right? So it's up to you which one you start with. I'll just go ahead and start with, I'll start with the if parallel lines one. So if parallelogram, and please make sure you are writing it exactly like it says it on the yellow sheet. Even though we are not going to necessarily show both pairs, you do want to write it just like this, because that's what's true about a parallelogram. So we're actually writing down the definition. If parallelogram, then both pairs of opposite sides parallel. Oops, running out of room. Okay, whoops. We want to say parallel. Okay, so both pairs opposite sides parallel, that's for step 2. And so when I come over here for my statement, I need to show which side lengths are parallel. And so technically I have 2 pairs, but notice I'm only using the pair that's going to give me, and again I can use, I can either use a different color to show this, but I'm going to try to get these alternate interior angles and look carefully at which lines they're touching, because remember, it makes a difference. They're going to create these as parallel, and then those will be alternate interior angles because they're touching those parallel lines. Okay, so we want lines, PQ is parallel, and we're going to write it as RS, because remember yesterday we saw that the opposite angles are congruent, but we're not really proving those are congruent right now. Okay, so that's what we know so far. They're parallel lines, just these ones. I don't care about the other ones. Even though they're true, I don't need them in my proof because I don't have any alternate interior angles. If instead you were working with these triangles instead, the smaller ones, then you would show the other 2 lines were parallel to get those alternate interior angles, because those ones touch, oh wait, no, I'm sorry, it still touches the same line. So, yep, both alternate interior angles, depending on whichever triangle you're going to prove, it still comes from this line. So now we can say the alternate interior angles theorem, if parallel lines, then alternate interior angles congruent, and write down what they are. So this would be, you could say JQX, angle JQX is congruent to. You could have said PQX, it's not wrong, it's just we should stick to the triangle that we're kind of like working to prove, and so that would be JQX with KSX. Okay, so there so far I just got an angle. I know that seemed like a lot of work just to get an angle, but we have one. And then we need, we have vertical angles for another set of angles here. And we have these 2 sides that are congruent as well. And again, I'm going to just use a different color here because I don't know it yet, but I'm about to show it in my proof. And so the diagonals bisect one another. That can be if parallelogram, then diagonals bisect each other. And remember, when you write this statement, all we're doing is just saying PR and QS bisect each other. And then the next step, you can use the definition for bisects. You can't jump right to just saying that they are congruent, or just that they're being separated into 2 congruent parts. So you have if segment bisected, then divide into 2 congruent segments. And then we can finally write down what the 2 segments are, which are QX is congruent to SX. Okay, so I got my side. And then finally, I just need my vertical angles to bring in my last set of angles. Vertical angles, then angles congruent. And the angles would be angle JXQ is congruent to angle KXS. You're still matching them all up just like we did before. And then finally we can say ASA, congruence, because that's what it is. This is definitely a longer proof than all of yours might be. On the homework, I believe they're a little bit shorter and easier to start with. And then we'll do more with it when we come back from break, of course. So the last part here for number 7 is write down the 2 triangles. So doesn't matter whichever way you want to write the first one. I'm going to just keep it the same as I already did up here, just because I know that already works in the correct order. And finally, step 8 is if triangles congruent, then all corresponding parts congruent, just like we were doing in Unit 4. And this would say Jx is congruent to Kx. And we're done. Okay, so this is on, the whole thing is on Canvas too, so of course you can check all of those. But again, if you want to watch the first one, like being explained, then that's going to be on Canvas. In addition to this last one, you do not have to do this, submit a picture thing in Canvas, but it is good practice, and it's a lot easier. It's only 4 steps. So if you want to try out number 3 down here, that's kind of the end of 5.2, 5.3 practice. And you can still do this practice that's on the previous page if you haven't done this one yet. This is also good practice. And then, of course, you have your homework for 5.3 you can work on as well, which does have 2 proofs on it. These are the type proofs, but notice they're a little bit shorter. They're not as lengthy, and then there's all this as well. Okay, so you'll have plenty of time in class to finish that up, and then hopefully bring all of your questions when I see you next.